In the past symposiums, we have already talked about several drive systems for C-frames. Today, we've talked very much about joining processes in order to show you what is happening in the NIMAC world. We've got the C-frame here with nut punching, and this is an application for clinching, all driven with a 6-ton electro servo drive with a driven nut or a driven spindle. The 6 tons are needed in order to make the required connection, the bond. The bond here with clinching requires about this tonnage in order to have a safe and firm bond. Basically, the C-frames that we supply are designed using FEM analysis, optimizing the process, first of all for the bending, but also for weight, for robot application, but also for stationary applications if you require higher stiffnesses. The C-frames are usually supplied with a process control. The process control or monitoring is normally designed in such a way that you use it with the current or also other forces. And you have a tool set, a die and tool set that we will see later. But let's first do a joining process now. As you can see, not very noisy, relatively unspectacular, but a very firm bond, maybe even a perfect connection.